Okay, g'day students. We're looking at precipitation reactions today. So we want to be able to apply solubility rules to determine the products of a reaction and see if we will get a precipitate. We want to determine the presence of specific ions based on the evidence of what's actually in the reaction. And we want to be able to communicate these with appropriate representations. For example, ionic formulas, chemicals equations, phase descriptions, in order to solve the problems and make predictions. So if we have a look at a precipitation reaction. A precipitation reaction is a reaction between two substances in solution in which one of the products is insoluble. So therefore a reaction between the cations and anions in solution, because we are mixing two types of ionic compounds together. The precipitate is a solid formed during a reaction in which two or more solutions are mixed. So the new compound will fall out of solution, and that's going to be called the precipitate. Now, a phase is a region of matter that is physically and chemically uniform in composition. So remember, solutions are homogeneous and there's one phase, but in a precipitation reaction we're going to end up with a couple of phases. There's going to be the solution and then there's going to be the precipitate. So I want to go through the first example with you, and we've got silver nitrate and we're mixing it together with sodium chloride. Now sodium chloride is table salt and silver nitrate has the formula of AgNO3, so Ag being silver. Now if I put silver nitrate and sodium chloride into solution, they will dissociate or ionize, and the cations will be silver and sodium in their separate solutions, and the other anions will therefore be chloride or nitrate. Now nitrate, remember, is a polyatomic ion, so that means it's made up of more than one atom. It's made up of 4 atoms. It's NO3+. So in the silver solution, we've got silver cations and nitrate anions. In the sodium chloride solution, we've got sodium cations and chloride anions. If we mix them together, there's going to be a reaction, and you can see the reaction here. We're going to form a cloudy white substance, and there's going to be a strong attraction between the silver and the chloride ions, enough to break the bonds between the silver in the water and the chloride in the water. So the forces are going to be stronger between silver and chlorine than those particles and water. And we're going to form a new product, and the new product is going to be called silver chloride, and that will fall out of solution and form a solid. So if I represent this as an equation, now you can see that I've got silver in solution, nitrate in solution, sodium in solution, and chlorine in solution. I have formed silver chloride, which is solid, and so it's not ionized, and I'm left over with sodium and nitrate in solution. So if I want to predict what is going to be soluble or insoluble, we can use solubility rules. And so what I've done is got the solubility rules out of your data book. And so let's try and predict what is going to be soluble here and insoluble. So we're mixing copper sulfate and sodium carbonate. So we're going to make, what do we need to think? Okay, let's draw a line between those and draw a line between those. We always put the positive one first, the most positive. So we're going to make copper carbonate and sodium sulfate. So let's look up our two ones. So we've got sodium here and carbonate. So let's find the intersection between those two, and it tells me that it is soluble in water. So it's more soluble than 10 grams per litre. So sodium sulfate is soluble. Sorry, sodium carbonate. What are we going to look at? Sodium sulfate. Let's look at sodium sulfate as well, because I just made a mistake there. Sorry, folks. I'll go along and look there and look at sulfate. Yeah, that's soluble. And what's the other reaction? It's going to be copper carbonate. So I look at copper. So copper, there we go, and carbonate. And what do we know? We have no data on that. In fact, it's actually going to be a form of precipitate in this case. And this is what we call a precipitation, I suppose. That's the solid that will form. Let's have a look at another one. We've got silver nitrate and potassium chloride. So what are we going to do? We're going to match up silver chloride and potassium nitrate. And let's look at, first of all, potassium nitrate. So here's potassium. Here's nitrate. We'll go to the intersection. And we're said to be S for soluble. So yes, that should be dissolved in water. So we want to now look at silver. Okay, silver chloride. So we go chloride. So we go along, and yeah, definitely that's going to be insoluble in water. So that one should form the precipitate. Finally, we want to just talk about net ionic equations. Now, your syllabus will just call this ionic equations, and we'll talk about that in a sec. So, consider when silver nitrate and sodium chloride react in water to form solid silver chloride and sodium nitrate. As they are ionic, those reactants separate into their ions, as we saw. So we've got silver and nitrate and sodium and chloride ions in solution. Now, the reaction has taken place because a new substance has been formed. And if we were to write this as a complete ionic equation, I've written all the ions available there. And what we can do is eliminate those ions that do not actually take part in the process, and we're going to call this a net ionic equation. Now, those those ions that do not take part in the equation are called spectator ions. So if I have a look here, I can see that I've got silver chloride formed. So that's the important part. So I remove the sodium, I remove the nitrate from both sides of the equation. So there's the sodium and there's the nitrate. And so what I can form, oh, I've done this the long way. A net ionic equation of silver ions plus chloride ions in solution will form solid silver chloride. So today we've looked at solubility rules to determine the products of a reaction. We've looked at the presence of specific ions, particularly considering the net ionic equation, and we've represented this in a variety of different ways to solve problems. When you're good there, you can move on to the mastery exercises.